Hi, my name is Rohit Ram. I'm a PhD student at the University of Technology Sydney and the primary developer of Birdspotter. This work is a collaboration between myself, Chiu Kong, and Marian-Andre Rizoi. All the code that you see within this presentation can be found through the QR code to the Birdspotter GitHub repository. Over the last decade, we've seen an increase in the usage of social media, and the impact it has had on our society have been significant. The advent of social bots, the divergence of political leaning, and the spread of disinformation have been concerning for our institutions. Researchers increasingly try to understand such online phenomena. Political scientists, sociologists, and data practitioners curate expansive datasets with this goal in mind. However, they often face a lack of tooling when trying to analyze these datasets. Birdspotter is a tool for analyzing and labeling Twitter users. It provides several contributions to the research community. Firstly, it's an easy-to-use Twitter analysis tool designed for political scientists, sociologists, and data practitioners alike to model the attributes of Twitter users and label them. It comes pre-packaged with a state-of-the-art offline bot detector and quantifies influence via a tweet dynamic system. It comes with an accompanying intuitive visualization, Birdspotter ML, for dataset exploration and narrative construction. Finally, it has a versatile label classifier, which can be applied to a diverse range of use cases, like those I mentioned before. In this video, I'll give you a peek under the hood at the technologies that Birdspotter uses and the features that it decides to focus on. I'll go through a basic walkthrough of the Birdspotter workflow and show you how to make some simple visualizations from it. Finally, we'll customize Birdspotter to a use case other than bot detection, in particular, political leaning. We'll start by looking under the hood at the technologies that Birdspotter uses and the features it decides to focus on. We can delineate Birdspotter into two systems, its labeler and its influence quantification system. The first three feature sets here relate to the labeler. The Twitter user features are engineered from Twitter user attributes and include things like the follow count, the number of years on Twitter, and the statuses rate. If, for example, the statuses rate of a user is high, this may indicate that they're a bot. If the years on Twitter is low, this may indicate that they're a sock puppet account. As such, we have informative features to represent our users. The semantic features relate to the language of users. We embed a user's tweets and their description using fast text word-to-vec embeddings, and as such, have a representation of their language. The topic features relate to the hashtags that a user tweets with. We TF, IDF, encode the top 1,000 most frequent hashtags within a dataset. The retweet dynamics relate to the influence quantification system. We use the timing and follow counts of tweets/users to reconstruct an expected retweet diffusion of a cascade, which we'll explain in a few slides. By default, Birdspotter comes with a bot detection labeler. The current state-of-the-art bot detection system is Bitometer, an online API which is often prohibitively rate-limited for expansive datasets. On this graph, we show the mean awk over a 10-fold cross-validation for Bitometer. Awk is a classification metric. Birdspotter, unlike Bitometer, is an offline bot detection tool, which means that it can be used efficiently on curated retrospective datasets. This graph shows that Birdspotter has comparable evaluation metric to Bitometer. We further perform an ablation study on the features within Birdspotter to determine which features are most informative to bot detection and find that Twitter user attributes/features are the most informative. Despite this, we keep all of the features within Birdspotter in order to diversify the feature set and allow for more expansive use cases. The influence quantification system works as follows. The influence of a tweet is determined as the number of descendants it has within the diffusion scenario. For example, this tweet here has a high influence because it has a large number of descendants, while any of the leaf nodes have a low influence because they have no descendants. The problem is that Twitter does not provide the structure for us, the retweet cascade. Instead, we have to reconstruct this. We use the number of followers associated with the user for that tweet and the timing of tweets to reconstruct this structure and determine the influence of tweets and users. We'll now go through a basic workflow of how to use Birdspotter and start with the installation. Birdspotter is provided through the PyPy package system, which means that you can simply use pip install Birdspotter to get it. The basic workflow goes as follows. Firstly, we import Birdspotter. Then we use this constructor to extract the tweets from a tweet dataset. This tweet dataset is in JSON format, line delimited JSON, which is the standard format. In this case, we are looking at a COVID-19 dataset from January the 31st, 2020. This extraction process constructs all of the features that we mentioned before. We can then use getLabelledUsers to activate the default bot labeler and label the users as bots or not. In this step, we also identify the influence of users using the influence quantification system. Using getCascades data frame, we reformat the tweet cascades into a usable format such that we can extract the expected retweet structures from it. To recover any of the computed values, we simply look inside the feature data frame. For example, here we look at the botness and the influence of users, and we see these below. We can also construct simple visualizations from this. For example, here we look at the botness distribution of our users for the COVID-19 dataset. We see a number of humans. We can also look at the log ECCDF for the influence of users. We notice that this is a long-tail distribution, or rich gets richer paradigm. What this means is that a small minority of users have a significant proportion of the influence. We could also use the Birdspotter ML Visualization to explore our dataset. This is the Birdspotter ML Visualization. What we see here on the left is a scatter plot representing the users within our COVID-19 dataset. We see the y-axis represent the influence percentile of these users, and the x-axis represent the botness of these users. The colors of these points, or these users, represent the hashtags most used by that user. What we see from looking at the scatter plot is that the majority of your users have low botness, and they sit in the middle of this influence percentiles. Some users have high influence. If we investigate one of these high influential users, we can see their name, their description, various other attributes they have, and some basic statistics. We can also explore the tweets and the cascades that they participated in. If we look at a user from the right side of the botness spectrum, we can find a self-proclaimed bot, which suggests that our visualization is working. The complex nature of online phenomena demands diverse analyses. Researchers desire different views of their data. In this step, we customize Birdspotter for a different use case than bot detection, in particular, political leaning. We use a publicly available data set in order to construct a political leaning classifier. The dataset we use is the Twitter parliamentarian database. We start by taking the tweet IDs that they provide and hydrating them using TWARC in order to generate JSON file. We then filter these tweets to include only Australian politicians and label the politicians that come from right-wing parties as positive examples and all others as negative examples. We can do this with getBot annotation template, which provides a CSV, which we can then use with Excel to manually label our politicians. We retrain Birdspotter with these new labels, and we label all the users, including the users that politicians retweeted, with this new model. From a cursory glance, we see on this limited data set of just the politicians that on a 10-fold cross-validation, we get an average ORC of 0.986, which is a high ORC, which suggests that we're able to detect the political leaning of politicians quite well. But this doesn't tell us how well we can detect the leaning of other users. We take a cherry pick of those from the left of the distribution and from the right of the distribution of rightness. So out of the lefties, we've cherry picked these 3 users. They all have low rightness scores. We have 2 Guardian reporters, The Guardian being a left-leaning news organization, and we have 1 meme page supporting Bill Shorten, the left-wing former party leader. From the right side of politics, we have Gavin McCreeds, a former LNP, the right-wing party of Australia, campaign director. We have David O'Brien, who retweets conservative politicians, and we have the Mineral Councils of Australia, which supports the interests of the mining industry, a typically right-leaning industry. Today we presented Birdspotter, a simple, versatile, and powerful tool for analyzing Twitter users. It has an extremely simple basic workflow, which can be used on those curated datasets that practitioners likely have. We've shown how it can be customized so that it can be used with the broad range of use cases that practitioners are likely interested in. All the code for this presentation can be found through that QR code to the Birdspotter GitHub repository. I look forward to any questions you might have.